that is basically on P2P, so peer-to-peer networks. So you can choose either of these, and it is going to be uploaded on Moodle. Probably it has already been uploaded. So either of these you are going to do. So what is this raw sockets all about? Okay, so you know that sockets are kernel level data structures that allow your program to communicate over a network, and that you already know, and you know this very well. You have done a lot of manipulations of sockets, etc. You are playing around with sockets. And so, but as I was telling you that you have been dealing with only two types of sockets, either the TCP socket, which is sock stream, or the UDP socket, which is sock datagram, right? This is what you have been dealing with. Achha. Now, as the packet basically, so this is basically, it is implemented on the transport layer, right? So now as the packet basically reaches up the transport layer from the bottom ones, right? So bottom one means what? Network layer is there. So as the packet basically reaches the transport layer, the different protocol headers are going to be removed, and only the payload is delivered to the top layer. So which means what? So basically, if you remember in the theory I taught you in the very beginning only, that you have, let us say, if we are talking about OSI, you have from the sender, at the sender you have 7 layers, at the receiver you have 7 layers. So these 7 layers are starting from the physical layer at the very bottom all the way up to the application layer, right? 7 layers. So what happens is basically, different types of applications are run on top, and then underneath basically you have this transport layer which is dealing with all these sockets, etc., right? So in transport layer you already know that there are, no, you do not know, but I will be teaching you sometime this week only, that basically, there are two transport layer protocols which are very popular. One is called the TCP, the other one is the UDP. But you already know one thing, that in your client server programs that you have written, that these are the two different types of socket streams, right? Sock stream as well as sock diagram. Okay, so this you know, although you do not know these protocols very well, which I will teach you in detail this week and next week. Okay, now the so this is so what happens, as I was telling you, that basically, the applications basically they have some payload, and that payload, when it is pushed down from the sender, basically, all the different headers from the different layers get added up, right? And then this we know, and then it goes through the physical medium to the recipient, to the receiver node. In the receiver node also, one by one the headers corresponding to these different layers, okay, so they are so they are taken out, right? So these headers were added to the payload from these corresponding layers at the sender, and once it is received at the receiver end, before the application gets the payload, basically these different layers, what they are going to do is they are going to take out the corresponding payloads for these different layers, right? So for example, transport layer has its own header, so the network layer has its own header, data link layer has its own header. So all these headers basically, these kept on, these were added in the sender side, and with the receiver side, one by one they are going to be taken away. Okay, so they are going to be stripped out, and so finally at the in the application level, so what is going to happen is that the actual payload is going to be received, which was sent by the application layer of the sender. Clear? So now, so the actual the application layer is going to receive only the actual payload from the socket, and there won't be any further headers, because these headers have been basically taken away by the corresponding layers in the receiver, right? So basically, normally, so we have been using TCP UDP sockets, right? But so TCP UDP sockets basically, so you have to follow this header structure, etc., etc. But there is something which is called this sock stream, this raw sockets, basically, using which you will be able to bypass all these different layers, and you do not have to really deal with all these headers corresponding to these layers. So you will be able to bypass, and basically, so the actual message basically can be received at the application level, right? So when I give you some example, that at that time actually you will be able to understand. So as I was telling you, the raw sockets basically enable you to bypass the kernel level network stack implementations to get the actual data packet directly from the data link layer and see whether it is in the proper format or not, right? So this is what. So from the direct data link layer, it will be received at the application level, right? So it will be bypassing all the layers in between. Now this data link layer basically, what it does at the receiver end, it receives the packet from the physical layer interface, right? So this is very clear. So basically, the receiver, the physical layer of the receiver will act first, right? So the physical layer passes the data onto the data link layer, right? So the data link layer, what it will do is it will receive the packet from the physical layer. And this physical layer could be, any of these interfaces, like if it is the wired internet, then it could be the ETH. ETH stands for what? Ethernet, right? So the Ethernet interface is represented as ETH. So ETH in the case of wired Ethernet, and in the case of Wi-Fi, it is WLAN. So these different types of interfaces are there, and directly it sends the packet, which includes the actual payload and all the protocol headers of the network stack up to the application layer, right? So this is what it does. So I will show you pictorially also to clarify, this particular concept. So using a raw socket, actually what you can do, you can extract the packet header data and other metadata in addition to the payload data from your code, right? So basically you can understand that it is bypassing all these different protocols that are in place, and it is making it like available in the kind of raw form. That is why it is called the raw socket. So raw sockets basically are typically used in different packet sniffers. There is Wireshark, right? So Wireshark, in the first class I had given you a demo of Wireshark. So packet sniffers like Wireshark, TCP dump. So they basically, what they do is they use the raw sockets, so they basically operate in the promiscuous mode, whereby you can capture all the packets that are traversing through your interface and analyze them. So this is this promiscuous mode. In the promiscuous mode, basically all these, all the packets basically, whether it is destined to a particular node or not. If a particular node is operating in the promiscuous mode, that means that all the packets that are passing through it, maybe it is not destined, all these packets may not be all destined to that particular node, but they are all passing through that particular node. So these packets are all going to be so visible to that node. So obviously, as you can understand, that if we are bypassing the protocols, etc., these different layers, etc. So basically, what we are doing is we are basically opening up, to different varieties of different security issues, right? So that's a drawback of use of raw sockets. So typically, that's the reason you do not use raw sockets. You continue to use this, what is it called, the TCP and the UDP sockets. You do not use typically the raw sockets, but sometimes basically like TCP dump or whatever, if you really have to get an understanding about what is going on or what is going wrong with a particular node, so you take help of these raw sockets. So this is what I was telling you earlier. So normally what you do, so you have the network interface card at the very bottom, right? This is this network card, as you call. So this network card is there at the very bottom. Then you have these different protocol families and the corresponding routines, and then IP processing, TCP UDP processing, socket interface, and on top you have the application, right? So you have all these different typically, so when you are using the sock stream or the sock diagram, typically, so it goes through all these layers of processing. But using raw socket, what you are doing is you are bifurcating, you are basically bifurcating from this protocol family handling routines at this layer. You are bifurcating, and through this Linux protocol family, you are basically bifurcating and bypassing all these layers in between, including the network layer, transport layer, etc., and then making all this data available through the raw socket. This is called the raw socket, right? So through the raw socket, basically you are making it available to the application. So this application could be Wireshark, or this could be a TCP dump, or any other different types of applications. So these applications actually have this specific requirement of getting visibility of what is going on with the data, whether it is in the promiscuous mode or in the non-promiscuous mode, it doesn't matter, but you need to get complete visibility of the data that is that is passing through a particular node, and that is where basically this raw socket can help you. If you were to use the TCP or the UDP sockets, so there actually you cannot do this kind of bypassing. Okay, so what are the different parameters that are used? So like before, right? So typically you used for creating a socket, so instead of AF packet, basically you used to use what? It is the IP packet, I think. So what is it called? IP packet or something like that, right? So here actually it is AF packet. So AF packet, then you have this sock raw. So this sock raw basically is the socket type, right? So here, because you want to use the socket type as the raw socket, basically the type is sock raw. And then you have the ETH-PALL. ETH-PALL basically will capture all the network protocol packets, and there is an alternative which is the ETH-PIP, which will capture only the IP packets. So basically, typically for this kind of debugging, etc., you would like to, in most cases, you will like to, capture all the network protocol packets, right? But if it is an IP network, whether it is ETH-IP or ETH-PALL, they are all going to give the same packets, right? So so this is basically the sock underscore R. So obviously, this descriptor basically, so if sock underscore R is less than 0, then you print that there is an error in the socket, right? Obviously, so it has to be greater than or equal to 0, right? So negative value is not allowed. So negative value means that if there is some kind of an error while creating this socket. Okay. So that's all basically. So this is the basic idea. So I mean, more or less the same like what you have done so far, but here actually you will have to use little bit of different parameters in order to create the socket and do few other manipulations. So this is the basic thing basically, and then so you will have to think little bit, and you will have to refer to some manuals for doing the assignment that has been given for you. Any question on this part before we go through the assignment? Okay.